All right, everybody, welcome on in. Hopefully we get a few more people showing up here in the next few minutes. Tends to happen. So we're continuing our discussion. So we talked last time about lines and slopes, and we kind of got into, we began our discussion of lines. We talked about how a line is really a collection of points. We think of it as like one solid object, a line, like a bar, you know. But really what it is a collection of points. Each of those points represents a solution to an equation, the equation of the line. So you can go both ways. You can figure out a solution and plot it on a graph, or you can look at the point on the line and use that to come up with a solution. It works both ways, and you want to be comfortable with both. We talked about slope, which is a measure of the steepness of the line, right? Is it horizontal? Is it steeper? Talked about how that slope was a rate of change. Okay. And we had the formula for calculating the slope. How do I calculate when a slope is very slight? Like, you know, if you're going on a walk and your slope is not too steep versus, you know, 45-degree angle or something like that, right? So we looked at the slope formula. We were able to calculate that. And then we talked about Y-intercepts. The Y-intercept is where your line crosses the Y-axis. And we saw that that point can be important because of that can give you an initial condition. It can give you information about the problem that you didn't start with. Oops, and it looks like I closed my tab for Delta Math. So let me reopen that. I don't want to do it on screen so I don't flash people's grades here. Thought I had it open, but I must have closed it. Right. Okay, so I'll show you some stuff. We'll talk about, we'll look at some problems from the homework and stuff like that, and then we'll kind of go from there, okay? So let's start with, this should be fine if I put that up there. Let's start with graphing lines from equations. So how would we go about doing that? Well, when we're in this is a special form of the line. This is what we call slope-intercept form. A lot of you may remember this as y equals mx plus b. You may have heard that before. Y equals mx plus b. That's a thing people remember, right? 10 years after they've left college, you bring up the equation of a line and they'll go, oh, y equals mx plus b. Now, they might not remember what that means. You go, okay, can you graph a line using that? And they'll go, oh, I don't remember how to do that. But they'll remember the phrase y equals mx plus b. And it's because it's a form that is very useful. Now, you might think, why do we have to have these fancy ways of graphing lines? You showed us how to graph a line before. We would just plot some points, and then we draw a line through it. Well, why do we need anything fancier than that? Well, it saves you a lot of time. Like, graphing lines is a topic that's one of the most important topics in algebra. There's some really, really important ones. Graphing lines, factoring. Those might be the biggest two coming out of algebra, right? The other ones get used, but graphing lines and factoring get used almost everywhere, right? They get used all over the place. Factoring doesn't really come up in statistics, but it comes up in all of your other math classes that you will take once you get to the college level math classes, the ones that are transferable to like university and stuff. All of those except for maybe statistics and maybe the topics course, you're going to be factoring. But all of them use lines. Statistics, you have to graph lines. Because a lot of times what you do is you get a scatter plot, and then you try to find if there's a line that describes your data really well. You put a line through it, so you use it in statistics. You use lines in college algebra. Calculus. A lot of times people think, oh, calculus, that's really advanced. Once I get to calculus, why would I be talking about something that I learned in beginning algebra? And actually, a major part of understanding calculus involves graphing lines and fitting a line to your graph. So you'll have like a really sophisticated graph, like a polynomial, and then you'll put what's called a tangent line on it, where the tangent line comes up, it just touches your graph just at one point and then keeps going. Those are extremely important. If you don't understand what a tangent line is, you basically don't understand even the beginnings of calculus. So there's a tendency, excuse me, for students to think, well, once I know once I learned this in beginning algebra, let's move on. And then when we get to calculus, they can't graph a line because they forgot how to do it and they don't really remember and they think, I don't need to learn that. That was beginning algebra. But it's a very important step in calculus, trigonometry, pre-calculus, statistics, all those courses. You're going to have to graph lines. That's why it's super important. And since you do it so often, you want to be good with it. You don't want to rely on the primitive tools that we use for graphing. You want to have the sophisticated tools so that, you're done with the problem in a couple seconds, whereas the person next to you is taking 3-4 minutes to do the problem, and you're like already on to the next thing. You've moved on and you're moving forward, right? It would be like asking, they had tools in the Stone Age. So like, why did we move on to the Bronze Age? Why did we have to do that? Why did we make fancier hammers and axes if we had like rocks and sticks in the Stone Age? Why did we move on, right? Well, it's because we end up with better tools, right? So that's what we're going to do here. So let me give you a quick intro, and then we'll get into things. So this form is called Slope Intercept Form. And it's called that because the form includes the slope and the intercept, right? I know a lot of times in like science, you might have an equation that's named after a certain individual or something like that. But in algebra, we try to name the things what they are. So slope intercept form, you can remember that because it includes the slope and it includes the intercept, okay? So y equals mx plus b is the form that you... Oops, looks like I'm not on screen. Where's my... Oh, here we go. There's my writing that I'm trying to have show up here. I can move this over. Y equals mx plus b. So in this case, m is the slope. M is the slope. And 0b is the Y-intercept. This is super handy because that means if you have the equation of your line in this form, you don't have to calculate the slope. You don't have to take the slope formula out and figure out what the slope is. You don't have to do any kind of calculations. You can just look at it, and some of you will get to the point where you look at it and you know how to do it in your head. You go, oh, yep, I can visualize it in my head. Some of you not as good as visualizing graphs. That's okay. You'll just have to graph it on something, and then you can look at it and go, oh, I get it. But that's nice, right? If I give you a problem and I say, I can give you a problem, and I can give it to you in a really mixed up form where you have to do a bunch of simplifying in order to figure out the slope and the intercept, or I give you the option, I can give you this equation in the form where you can just look at it and tell what the slope and intercept is, which would you prefer? You'd rather it be in the easy simplified method, right? Of course. So, for example, let's say I've got the equation y equals 2/3. Oops, thought I was in another piece of software for a second. 2/3 x. Why don't I move this over? You don't need to see the code. You just need to see the output. Y equals 2/3 x minus 3. Okay, so let's say that I need to graph this, or at least understand it. Like right now, because I'm good with slope and intercept, I can visualize this graph in my head. It might not be exactly perfect, but I have a basic understanding of what's going on with this graph just by looking at it. So what am I doing? What am I analyzing when I look at this on the screen and say, yeah, I have a good idea of what that line looks like? Well, I'm doing two things. One, I'm looking for the slope. The slope is your coefficient on x, right? That's the m. The m is the coefficient on x. 2/3 is my slope. Okay, so I know that. Notice I didn't calculate anything. All I did was look at the problem. Okay, so slope, let's go ahead and write it as m equals slope equals, in this case, two-thirds. Okay, so I know my slope. Remember last time we had to take points and we had to calculate the slope? I didn't have to do that. All I did here was look at my problem and say the slope's 2/3, right? Because I know my slope-intercept form. Okay, so what about a point, right? There's lots of lines with slope 2/3, right? I'll show you. Look at these. In fact, let's move this over. y equals 2/3 x plus a, and we'll use a as a slider. All of these lines that I'm showing you right now, as I slide this line around, all of those have a slope of 2/3. Okay, they all have slope 2/3. So what we need is to know a point on the graph so we can pin it down. And I can know, is it this line? Is it this line? Is it this one? This one? This one? Which one is it? So we need a point to pin it in place. The easiest one to use is the Y-intercept. Why is that the easy one to use? Because it's staring me in the face right here. Remember, your intercept is given by the B. So you take that B and you make the point 0, B. And then that's your point. Your line goes through that. So I would say, okay, for the example that we are doing, I know that 0, -3 is a point on the graph. And so the fact that it's a point on the graph is going to help us graph it. But even more important, it's the Y-intercept. And that might tell us something about the problem that we're working on. That might give us some information that we didn't previously know. Okay, we added that information by being able to interpret the graph that we're looking at. So here's how I would do this. If I know that my graph goes through the point 0, -3, and I know that my slope is 2/3, then how would I graph this? Remember, slope is rise over run, rise of 2, run of 3, and we know that we have the point 0, -3. That's all we need. Watch. So let's close that down for a minute. So I'm going to graph the point 0, -3. You can see my point down here. Let's make this a little more obvious. Let's do that. There we go. 0, -3. You can see my point right down here. And my slope was 2/3. So rise of 2, run of 3, they're both positive. Okay, so I look at this and I say I'm going to go up 2 and over 3. That means that 3, -1 right here, that's another point on my graph. 3, -1. And then if I was doing this on a piece of paper, I was making this graph by hand, I would just get the edge of a book or a ruler or something, and I would draw a straight line through here. And there's my graph. So it should look like that right there. There's our line. Okay, see how easy that was? There was no calculations or anything to do. I took my Y-intercept, I plotted the point. I used my slope to go up and over, made my second line, draw a line through it. Not bad, right? I didn't have to calculate anything. So to the question, why do I have to learn this y equals mx plus b if I could just plot points and do it? Because this was faster and easier. And in math, faster and easier should also be taught as faster, easier, and less mistakes. Because the easier something is, the less mistakes you're going to make, right? Okay, so how would I do this delta math problem? Same way. What am I going to do? I'm going to start, let's see, looking at this. I can see that it's in slope-intercept form. So that means my y-intercept should be, I'm going to give you a few seconds to figure it out. What should your y-intercept be? What is the point that I'm about to plot on this graph? Can you answer that to yourself? Using this information that we just learned right over here, interpreting it as slope-intercept form. Well, looking at it, my intercept is 2. My b is 2. So that means my y-intercept is 0, 2. So I'm going to go over and I'm going to plot my first point on 0, 2. Okay, it's going through that point right there. Okay. Now, how do I come up with the next one using my slope? Well, we have to be careful because see how that negative is in front, -1/3? That's a legitimate way of writing fractions. You also could write that fraction as -1 over +3. And some people get nervous about this because they've kind of been trained. It's kind of like, your teachers have trained you not to do this. And so people, you kind of get anxiety when someone tells you to do it. You can also represent this fraction as 1 over -3. Now, that's okay to do when we're using slopes. A lot of your teachers aren't going to like it when you use a negative in the denominator. In my opinion, it's a little old-fashioned, but it does make it a little bit simpler to not have negatives in the denominator. The way math is done these days is not really a big deal. But you'll have teachers who get grumpy at you if you leave a negative in the denominator. But I want to show you how it works both ways, okay? So we can view, let me write down what I'm saying in case you're not quite following. keep in mind that the fraction negative 1/3, that's the way it's written in the problem, is negative 1/3. This is equal to the fraction negative 1/3, which is equal to the fraction 1/-3. These fractions are all mathematically equivalent. You're going to have teachers who panic if you write it this way, so don't get in the habit of doing that regularly. But for slope considerations, it's okay, because we know that all of these will represent the rise over the run. So that means that negative 1/3 actually gives me two different ways of interpreting my slope. I can think of it as going down 1 and right 3. That is negative 1 for a rise, positive 3 for a run. Or equivalently, I can think of this as going up 1 and to the left 3. So a rise of 1 and a run of negative 3. And you go, well, how could those be the same? Those are different things. How could going up 1 and to the right 3 be the same as going, did I say that backwards? Going down 1 and to the right 3. How can that be the same as going up 1 and to the left 3? Well, I'm going to show you. Okay, so watch. If I start here and I go up 1 and back 3, 1, 2, 3, that's the line I get, right? So look at that. Kind of hold that line in your head for a second. In fact, well, I can leave this one up here and I can just do it from here. What was the other way we considered slope? It was to go down 1 and to the right 3. Well, look, if I started here and I went down 1 and to the right 3. Yeah, sorry, it's hard to see. It's a small graph. Right 3, I end up, notice if I made my point here, it would give me the same line. So you can interpret the slope either of those ways. You can't leave the negative out in front. You have to either put it in the numerator or put it in the denominator. For what we're doing here, putting it in the denominator is fine. Just don't do that in your algebra. Your teacher's going to get anxiety, okay? Let's submit my answer. Yes, I'm sure. Look at that. We got it right. Okay? So here they put the negative in front, which is kind of the common way to do it. Actually, or they put it on top, so you go down 1/3. So why can't you just always use that? Well, think about it this way. What if you're doing a problem? What if you're doing a problem where here our slope, wait, is that the same problem? Oh, it's almost the same. It's negative 1/3 x minus 2. What if you were doing a problem where you were over like in the corner? Well, I don't have any room to go down 1/3. I'm off the graph, right? Well, I can't do it. There's no grid over here. I've run out of room. So in that case, I would have to go the other way and go, I would go up 1 and back 3. And then I could get my line that way. That's the main reason why you would want to do that, right? So it doesn't make sense for this problem, but I was just showing you why we might do that. Okay, let's actually do, I'll get this one wrong. I want to move on to the next one. Uh-oh. Did I make it mad? What's going on? Looks like my Delta Math locked up here. Okay, let me restart it here. Oh, some kind of error page. Maybe Delta Math itself just went down. Oh, here we go. Back up. Their servers must have just hiccuped for a minute or something. Okay, so that's using your y equals mx plus b form. There's another form of a line that you need to know. Point slopes later. We'll get to that a little bit later. Finding the slope graphically, we looked at that. Let's do a problem, but we kind of talked about this. Draw a line representing the rise and a line representing the run of the line. State the slope of the line in simplest form. Let's see. I have to remember what they want here. I think they want us to just do like that. Is that what they want? Oh, no, it isn't. Yeah, I think they do. Draw representing slope 1, submit answer, yes. Oh, it didn't like something I did. That's kind of a weird question. Draw a line representing the rise and a line representing the run of the line. State the slope of the line in simplest form. Let's see, what was it? I went down. Oh, because it's -1. Of course. Sorry. That was my bad. I'm trying to read what they're doing here. Let's do one more. Okay. Draw a line that represents the rise and the run of the line. State the slope of. Okay, so you started a point on the line, and I would go down 1, and then I would go over 2. See, that puts me on the line. So you're just drawing the lines that get you back on the point. But if I go down 1 and over 2, that's -1/2. -1/2. And there we got it. Right? Wasn't paying close enough attention to that first problem. But did you see that's how you do the problem? You're signifying that you understand the slope. You're going down 1, you're going over 2. That's putting you back on the line. And when you put those together into one fraction, you get -1/2 as your slope. Okay, so that one's not bad. That one's pretty straightforward. Graphing this form. So this is what's called the intercept form, or what we'll later call standard form when we get into systems of equations. A lot of times we want them in this ax plus by equals c form. Why is that helpful? I'll show you. It can sometimes be helpful. I think that sometimes the books overemphasize this form and make it seem like it's a lot more helpful than it is. But it can be helpful for really simple problems. For example, let's do 3x plus 5y equals 15. That's what our line should look like. But how do I know that? Well, let's take 3x plus 5y equals 15. Let's do it over here. 3x plus 5y equals 15. Okay, so let's pick some x values and some y values and figure out what the points are. This is like the plotting points that we talked about last time. So what if I say, what about when x equals 5, basically let's make it when x equals 0. The intercepts happen when one of your coordinates is 0. If your x is 0, then that's your y-intercept. If your y is 0, that's an x-intercept. Okay? So when x equals 0, what happens? Well, that means that my problem becomes 3 times 0 plus 5y equals 15. Right? So that just becomes 5y equals 15, which we can see then y equals 3. So that means that a point x equals 0, y equals 3 is a point on our graph. So that we can go graph the point 0, 3. So I should be able to graph that 0, 3, 0, 3. So that's the intercept. See how it lies right on the y-axis? By plugging in x equals 0, I was able to get to the y-axis. Okay. Well, there's another intercept. There's an x-intercept. So now we're going to play, whoops. Now we're going to play, I keep clicking the wrong thing. Now we're going to say, we just said, what about when x is 0? What about when y is 0? Let's plug that in. So when y equals 0, then we get 3x plus 5 times 0 equals 15. So 3x equals 15. I think I'm going to be off screen here. So x equals 5, meaning that we have the point. We'll take those two coordinates together. We have the point 5, 0. Okay, so now I'm going to go graph that. 5, 0. I've got my 2 points. My line should go right through it, so I would take some straight edge, draw a line through there, boom, put it in there. There we go. Got your line, right? And we're good to go. So you got it. So that was pretty easy. So I go, that seemed really easy. Why don't we just do that all the time? Well, it's harder when you have something like this. 3x plus 5y equals 7. Let's get rid of these previous ones. What do you notice about our intercepts for this equation? 3x plus 5y equals 7. Looks like your point doesn't fall on a nice grid line. It's going to be fractions. You're going to have fractions when you're doing this problem. And look for this one too. You're going to end up with fractions over here. So the problem is that most of the time you end up having to use fractions. We didn't have to use any fractions in the last method we used. We didn't even have to calculate anything. We just plotted stuff on here. Whereas here, this algebra part, a lot of times you're going to end up getting fractions. So it can be helpful to use the Y-intercept method. Good to know, good to understand, because it helps you understand lines better. And when you do need to know how to get the intercept, you go, oh yeah, I know how to get intercepts. For the Y-intercept, I plug in x equals 0. For the Y-intercept, for the x-intercept, which one did I just say? And then backwards the other way. So to get the x-intercept, you plug in y equals 0. To get the Y-intercept, you plug in x equals 0. And you go from there. But as far as graphing, not always super helpful. But you should know how to do it. Okay, so let's go back. What else do we need to look at today? Finding the slope from points. We did that one already. We did this last time. Just use the slope formula. y2 minus y1 over x2 minus x1. Remember we did those calculations last time? That's what you're going to do right here. Okay, here we go. Here's the point slope I was talking about a little while ago. Line equations from point slope. Okay, so here we have now another form for the equation of line. You know how we talked about y equals mx plus b a moment ago? We have another form. It's a little bit more complicated than the y equals mx plus b, but they like us to teach it. Here's what you should know. You can always use y equals mx plus b if you want, right? I think a lot of times in the class we teach students different methods and they learn. It is true that sometimes it's, well, some people would argue. I would say it's actually the same amount of work. Some people argue that certain problems are easier using point slope form, which I'm about to show you. I've written it out both ways in class before, and it's like, look, it's literally the same number of lines. It's the same amount of work. But people really like to show point slope form. When I'm doing actual work, I always use slope intercept form. I use it for the problems that you're supposed to use it for point slope form. I use it all over because it's honestly it's the best form to use. So some people like point slope form, but you have to know it for algebra because we have to teach you. But the truth is, if you're really comfortable with y equals mx plus b, you'll be able to do whatever you want to do with lines. Every homework problem, you can do it thinking about it in terms of y equals mx plus b. But there's this other form that that I have to teach you. You should be aware of. It's called slope. It's called point slope form. Okay, and point slope form looks like y minus y1 equals m times x minus x1. Okay, that is your point slope form. Again, we call it what it is. What do you see when you look in there? Well, I see the slope because there's that letter m. And what is x1, y1? That's a point. So we can say that this form has slope m and passes through point x1, y1. You gonna compile for me? There we go. Okay, so x1 and y1 are the coordinates from a point, and here's your slope. So if you're doing a problem where they say find the equation of the line that has this slope and passes through this point, you can plug it right into point slope form. You can also use y equals mx plus b. It's like people tell me, oh, but point slope form is easier for this type of problem. And like I say, I write it up and go, look, count the lines. It's the same. It's not really easier. So I'm in that. Most teachers love teaching point slope form, but I'm in the camp of like, I'm of the opinion we should teach things when they add to our toolbox. We don't really need multiple things in the toolbox that do the same thing and don't make it easier. Right, but whatever. However you get the problem done, that's totally legitimate. So if you love point slope form, you're not wrong. That's fine. You can go with that. Okay, so how would we do this problem? All right, well, let's take this one in delta math. What is the equation of the line that passes through -6, 6 and has an undefined slope? I don't remember if I talked about this last time, but let's remind ourselves either way in case I did. You've got all these lines, y equals, let's make this a divided by b, x minus c. So a bunch of sliders here, so I can like, see how as I change a, I'm getting all these different slopes, and I can change b, and I get all these different slopes, bunch of lines with different slopes. Well, there's a couple of situations where we have to be careful with our slope. That is horizontal lines and vertical lines. So just think for a minute. If I have the line y equals 2, what is the slope of that line? What is the slope of that? Just looking at it without having to calculate anything. What number do you think would make sense to represent the slope of this line? If you were going on a hike and your friends like invite you to a hike and you're like, well, how steep is it? How steep is this? What is the level of steepness that it makes sense to put to this? 0. The slope is 0. There is no slope to it. Well, there's a slope, it's just 0. If you calculated your slope using 2 points, you would get in your numerator, you would get 2 minus 2, which is 0. And your final calculation for your slope, you see a slope with a line with slope 0, that means it's a horizontal line. The way we represent horizontal lines is just the equation y equals whatever the number is. So the horizontal line with height 2 is the equation y equals 2. Right? Okay? So that's 0 slope. The other scenario is when we have what some people would like to call an infinite slope, but that's not really right. I know it's reasonable to think about it that way. It's actually one of those mistakes in math that people that think it out go, shouldn't we call that infinity? Not exactly, but it's a good idea. But it doesn't hold up, right? It ends up falling apart. So this is not infinite slope. It is undefined slope. The reason that we say it's undefined is if you use the slope formula on 2 points on this line, you're going to get 0 in the denominator. You cannot have 0 in the denominator because that means division by 0, and division by 0 doesn't make sense mathematically, right? We call that undefined. It's undefined because it's meaningless. So think of it this way. If I ask you, what is 6 divided by 3, then I'm really asking you how many 3's are there in 6? How many 3's does it take you to add up to get 6? And the answer would be 2. If I say, what's 6 divided by 0, I'm asking you how many zeros do I have to add up to get to 6? No, it doesn't make sense. There is no number, right? Even some people might go, well, what about infinity? Add up an infinite number of zeros, you still have 0, right? It doesn't ever get you to 6. So it doesn't make sense mathematically to even give a number to this slope. So this is what we call an undefined slope. So an undefined slope gives you a vertical line, and we represent a vertical line with the equation x equals something. Okay, so for this question we have here, What is the equation of the line that passes through the point negative 6, 6 and has an undefined slope? Boom, right there. Red flag goes up in my brain, and I go, undefined slope? Oh, that's a vertical line. Right? So you can jump over to Desmos and go, okay, a vertical line. Okay, I need a vertical line, but I need it to go through the point negative 6, 6. So I put my point here, negative 6, 6. Okay, I need a vertical line that goes through this point. Let's play around here. Oh, there it is. X equals negative 6 is a vertical line going through negative 6, 6. They want the equation. X equals negative 6. Submit. Yes. Green check. There we go. Does that make sense? So you're going to get these different problems that give you clues, and you have to put the form together. In that case, we didn't even need the point slope form. Let's do another problem. Here, this one's a little better. I mean, at least as far as using that formula. What is the equation of the line that passes through the point negative 5, 7 and has a slope of negative 2/5? Now, there's a bunch of ways you could do this problem. Okay, and probably with the time left, I'll show you a couple of ways, because if you really understand these kinds of problems, you can do them in more than one way. Okay, and then when you can, you just find math to be a lot easier, because you can sort of think your way around instead of just trying to memorize it. So let's remember, negative 5, 7 and negative 2/5. Okay, so let's go back here. I've got negative 5, 7. And with slope well, let's write it this way, negative 2/5. So we have a point, negative 5, 7 and negative 2/5 is our slope. Did I get that right? Negative 5, 7 and negative 2/5. Okay, so that's the information from the problem. Uh-oh, I've got a typo. Okay, so we want to use point slope form here. Got negative 5, 7, the point negative 5, 7, and a slope of negative 2/5. Okay, negative 5 is my x1, 7 is my y1. So now I'm just going to rewrite this form up here, except where it says m, I'm going to put my slope. Where it says y1, I'm going to put my y1, which is 7. Where it says x1, I'm going to put my x1, which is negative 5. So rewriting that line, I get y minus 7 equals negative 2/5 times x minus negative 5. Now, some students panic when they have to put a negative number into a formula that has a minus. And they go, wait, what's going on? I've got 2 minuses there. Well, you did this in pre-algebra. What is negative 5? That's positive 5, right? So we would simplify this to be x plus 5. Right? Sometimes I get this question a lot. If you're like the quadratic formula too, where you have your negative b, and then students have to plug a negative in there, and they get all flustered. It's just negative 5. Negative 5 becomes plus 5. So you would write it this way. Now, usually for these problems, let's see what they do on here. Usually they want you to put it then in slope-intercept form. Here they don't specify. What is the equation of the line? So we might get away with putting it in just this way. I don't remember. Usually homeworks want you to put it in slope-intercept form. Let's find out. Let's see. Let's see if that works. Y minus 7. Y minus 7 equals negative 2/5 times x plus 5. Let's see if they like that. Oh, yeah, they liked it. Notice they put it in slope-intercept form. There, they have it in slope-intercept form. Actually, trying to remember. point slope. See, they actually do it the way I prefer to do it, which is they're using the slope intercept in order to do it, which is my preferred method. But we're supposed to teach you the point slope form, which is what I just showed you. But they got it a different way. So if you read the solutions to the problems, they're doing it with the slope intercept form. Either way is fine. Whichever way works for you, whichever way you prefer, just go with that. There's no judgment, right? If you use point slope form and it works for you, good. You're doing the problem right. Okay. If you like the slope intercept form, like my preference, good. I would argue it's better, but there's nothing wrong with doing it either one of those ways. Okay. You're still getting the problem right. Okay. Let's look at, just so you understand graphically, let's think about how you could even understand this graphically. How could you do this problem in a graphical manner? Well, let's see. We're supposed to go through the point negative 5, 7. So I would come over here on my graph, and I would put in the point negative 5, 7. Okay, there I've got a point. And what was my slope? My slope was negative 2/5. So I'm going to go down 2 and over 5. That puts me at the point 0, 5. Okay. Now I can use my understanding of slope intercept form to come up with the equation of the line, because what's my y-intercept? It's 5 right here. We just plotted that point, and we know the slope that was given in the problem, so the point should also be y equals negative 2/5, right? That was the slope given in the problem. X plus 5 goes right through there. And notice that that's the problem they give you right here. Y equals negative 2/5 x plus 5. That's what they end up with. So you can get it by looking at the graph. You can get it by using the point slope form. You can get it by using the slope intercept form. All of those methods work. And it's not, you might think, well, isn't one way this graphing thing? It kind of seems like cheating if I'm looking at the graph. No, you should know how to do all three. If all you ever do is look at the graph, then you're going to struggle. But if you can do all three of those ways that I just mentioned, you're not going to struggle with lines and statistics when the person next to you is like, I don't know, I learned how to graph lines like 2.5 years ago. I don't remember how to do it. And you're going to be like, no, it's actually really easy. Here's how you do it. Okay? So that's how we would do that. Okay? Let's just look at the next one. Yeah, same idea. So use any one of those three methods in order to get it done. Let's see, is there something I can go over in the meantime? Oh, right, and then they talk more about point slope. Looks like more formally point slope form here at the end. So so by the end of you doing this, and you have a little while longer, you've got over a week to do these homeworks. Yeah, you should be pretty comfortable with how to graph lines. Yeah, right. And then we've got, and then those are due about the same time. So we'll start going over that next week. Okay, so we kind of did this. We finished up this chunk today. And then we'll have this chunk next time for you to, looks like we have a bunch of stuff due on that 27th. So we'll move ahead into here next time and talk about that. Feel free to send me questions. Feel free to send me a screenshot of a question that you're struggling with, or ask me about a specific topic or any of those. We can talk about that stuff. Okay? So make sure you're watching the videos. Make sure you're doing the homework, all that kind of stuff. It's not really anything I can talk about in 3 minutes. So we will wrap it up there. Make sure you're caught up. Most of you are doing great. Most of you are doing fantastic. I think we're going to have a really high pass rate in this class. So keep that up. Keep doing that work. Just, it's early on. We're only, 20% through the class or something like that. So we have 80% left. Long way to go. But what I'm seeing from this class, I like. I think I'm going to be able to give a lot of passing grades, which I like to do. I would much prefer to give you a passing grade than a not passing grade. So please keep up that good work. Stay diligent about your homework and consistent. And then if you do start to have any questions or concerns, please come see me. And I can, in office hours, or if we need to schedule a different time to have a Zoom conversation, we can do that. and come talk to me. And I want you to successfully complete the course, but it sort of takes both of us for you to do that, right? It takes me working on helping you, and it also takes you working on helping you. Like I say, right now I see good signs. So have a good weekend, and I will see you next week. And I think we're good. So I'll shut off the Zoom. Shut off the YouTube. Anyone who wants to see me in Zoom, come talk to me in Zoom. I'll stick around as long as there's people asking questions.